Welcome to the Data Science A to Z Theory and Programming tutorial. In this short video, I will show you how to use Anaconda, Python Anaconda Spyder in order to do some matrix operations. Okay, so in order to use Spyder, Python Spyder, then you need to run first Anaconda. So if you just click on your search bar, then type in Anaconda. Once you type in Anaconda, then you will see Anaconda Navigator. Click on the Anaconda Navigator, then it will come up shortly. It will start shortly. Once Anaconda starts, you will see this Anaconda Navigator, and so then for the first time when you see this, then you can click on the Anaconda Navigator icon on the taskbar, and you can do right click here, and then you can pin this program to taskbar. So next time you don't need to type in Anaconda here on the search button. So then when you get your Anaconda Navigator, then you can click Spyder. So you see that I have already Spyders, and then Jupyter Lab, Jupyter Notebook. These are I have already installed. So this is why it is showing me launch button. So then once I click on the launch button, then my Spyder will start up soon. So remember that in order to use Spyder, you have to have your Anaconda Navigator running and up in the background. So do not close this, but you can minimize it. You can keep it minimizing. Okay, so my Spyder is running up. Meanwhile, I will show you in this short video how and what we will do about some basic matrix operations. So matrix operation is one of the fundamental topic of linear algebra. So if you do a Google search about basic matrix operations, then you will see some web resources, and then many online videos, and then resources about basic matrix operations. So here I have pulled up some matrix operation resources here from this site, and one of these site is from Stanford University's resource. So you can select in one of these, each of these link, and you can learn more about matrix operations. The basic matrix operations are matrix addition, matrix subtraction, matrix multiplication, so matrix inversion, transpose of a matrix, and matrix scalar operation, something. So each of these basic operations are explained with example in this website, so you can go through this, as well as I have opened another website. This is from George Brown University from Canada. So this website is pretty simple, and this is very straightforward. So I want to go through with some of these examples with Python. Okay, so you see that my Spyder is up right now, and then once my Spyder is up, actually what I can do, I can create file, and then create new file. Okay, then what I will be able to write my Python code over here, Python program code over here, or also I can click on file, then I can click on open, and I can open any file from my computer. Here that this is my data science A to Z this is my GitHub repository. I am putting all of my matrix operations over here. So maybe in this folder I have some already programs like matrix operations here, or maybe here. So let me show you how to open an existing file with Spyder. So I selected the file and click on open. So then you see that I have a bunch of some matrix operations. So let me go quickly one of these. Let me resize this window and make it side by side in order to go through some of these examples. Okay, so here on this side I have some web resource, one of the web resource, and on this side I have my programs. Okay, so I want to show you how to do matrix addition. So matrix addition is very simple. You see that you will add element by element. Okay, so this is a 2 by 3 matrix, and this is another 2 by 3 matrix. So in order to add these matrices, you will add element by element. You will add 8 plus 3, this is 11, then 4 plus 10, this is 14, 2 plus 4, this is 16, then 6 plus 5, 11, and then so on. So in order to do this matrix operation on Python, there is a built-in library. It is called numpy. This is called numpy, numpy. So, and then when you import this numpy, okay, so then you can use the numpy has, okay, some as a matrix. This is, it has matrix, what is called is matrix method. So you can use this method. So in order to shortcut actually my code, just I'm copying. Okay, so then let me put this code here in my new file. So then click up, I just pressed Ctrl plus V, paste, to paste this code over here. So how do I import numpy? So you see that if I do not import numpy, then it will show me an error or warning like this way. See, it is showing me an error. So then I need to do import, import, import numpy, numpy. Then I can keep it as numpy this way, but by shortcut I can give a shortcut name as np. So this np means this np is a shortcut of numpy. So then instead of writing numpy as a large name, I can use this as this np. So then how do I declare a matrix? So I will use matrix equal sign, then every element in a matrix is put within angle bracket or third bracket, we say. So then within third bracket, so here what are the elements? I have 8, 2 and 3. So the first matrix I would pay. So here I can do say let me, before I go to the matrix operation, let me explain how matrix method works with numpy. So then for instance I have this matrix is 1, 2, 3. So this is a very simple matrix. Okay, let me do this, make this matrix as 4, 1, 5. So let me make it 4, 1 and then 5. Okay, then the second 4, 1, 5, and the second row over here is 3, 6, 2. So let me do it, 3, 6 and then 2. Okay, so that means I have this matrix over here, matrix M, actually matrix M. Let me give it matrix name. So then I can print, if I want to print matrix M, then I have to give this name matrix M. You see that I cannot give matrix space M because in variables, Python variable does not allow to keep space in variable naming. So but I can give underscore M, that is fine, but I cannot give dash it will not take, but I cannot give space, but I can give underscore. So then, so this is the way. So for instance, if I write matrix, my matrix as this, and then if I want to print these elements, then for instance these two lines, then what I need to do, it will, I have an error over here, no problem, but I'm not running this line, okay, but it's okay. I have to run this line first. That means then I have to run this line first, so the numpy will be installed here. So otherwise your program will show an error. For instance, I'm showing you, if I just want to run this over here, these codes, then I will select it, will press Ctrl plus Enter in Windows, and in Mac I will press Command plus Enter. Then if I press Ctrl plus Enter, then it's good. It is showing me actually just previously I downloaded numpy, so this is why it is not showing me an error, but initially I should do this. I am supposed to do this. Okay, once you see that, once I run this program, then it is showing me my matrix is 415 is the first column, and then 362 is the second row. Actually 415 was the first row, and 362 is the second row. Okay, so this is matrix, just matrix, and you can go through these let me see how many operations it has. Okay, and it has this matrix, like the last, it has matrix transpose. Transposing a matrix means that, so you will put T at the top, that means you will convert this row into column, and that means your column will be converted into rows and your rows will be converted. That means transposing a matrix means converting its row into column, and that means converting its column into row. So if I transpose, for instance, this matrix 415, okay, 362, such this command will be np.transpose, and then within the transpose methods I will pass the matrix M as a parameter. Okay, so then I have this. So if I run this program, so you will see that I will get this is my original matrix 415, you see 362, and this is my transpose matrix. I have this 431652. So this is the transpose operation. So just I showed the first operation and the last operation. Now I will go through these middle operations very quickly. Okay, so another thing that it says, the next one, it says matrix addition. This matrix addition is very easy. So then what it will do, for instance, it will do, let me write it. First one, matrix A, for instance, my matrix A is 842, right? My matrix one is 842, and then 615, okay, and then my matrix B is 310 4, and then 561, 5 6 and 1. Okay, so I want to print matrix. Okay, then I want to make, for instance, matrix if I say matrix C, so matrix C equal to matrix A plus B, for instance. Matrix C will be this np dot matrix, then within the matrix operation method I will pass matrix A, and then here I will pass matrix B. Then my matrix C will be the sum of matrix A and matrix B. Then if I run this, then I will get output matrix C equal to, you see my matrix C equal to 11 14 6 11 7 6 11 14 6 and 11 7 6. So how would be if I would want to do matrix subtraction? Then similarly same thing, matrix A is this, matrix B is this, and matrix D, maybe my matrix D is matrix A minus matrix B. Then I will do matrix G print out over here. So then my matrix D will be matrix A minus B minus matrix B. So then 5 minus 6 minus 2, then 1 minus 5 4, 1 minus 5 4. Okay, so then here the next operation is multiplying a matrix by constants. Multiplying a matrix by constants is very easy. Okay, for instance, if I have my matrix A equal to this, if I want to do, for instance, my matrix my matrix E will be like 2 times my matrix A. Okay, so then what I will do, 2 times np dot matrix, and then here I will put matrix, what I will put, my matrix A, then I will print matrix E. Okay, I will print matrix E over here. So then once I got this, if I select this code and press Ctrl plus enter, then I got matrix E is the twice of matrix A. That means I am multiplying each of the elements by 2. Okay, so not only one element, I am multiplying every element by 2, every element. So 8 times 2 will be 16. Okay, 4 times 2 will be 8, and 2 times 2 will be 4, and 6 times 2 will be 12, 1 times 2 will be 2, and 5 times 2 will be 10. Okay, so this is the matrix constant. And how do we do matrix multiplication? You know, as matrix multiplication is little bit trickiest, so we need to multiply each of this row by corresponding column elements. So matrix multiplication is a little bit tricky, but here I will show you how we can quickly multiply 2 matrices. Okay, so for instance, if I have this, which one? Okay, for instance, let me multiply matrix A and matrix B, and let me make it matrix F. So then very quickly I can do like this way. So matrix A is this, matrix B is this, matrix, let me make it matrix F, and I will make it the multiplication sign over here. So then I will print matrix F over here, then I will press Ctrl plus enter. Okay, so the one thing that here another, so I did a mistake over here, because through matrix multiplication I do need to match my row and column. So this is 2 by 3 matrix, and this is also 2 by 3 matrix. So in matrix operation we cannot do 2 by 3 by 2 by 3 matrix multiplication. So I need to change this as actually, so I have here 2 by 3 matrix, so I need to make it 3 by 2 matrix or something, 3 by 4 matrix. So I can do this way. Okay, so then if 5 6 maybe 1 2. So then I have here is 2 by 3 matrix, and I have here 3 by 2 matrix. So then my multiplication will be 2 by 2 matrix. Now I should get an exact result. Now we see that I got an exact result for this one, but you can try it and manually, and I can check, and I believe the result is definitely correct. Okay, so one more last thing, maybe I can okay, I can check this one if my operation is correct for this one by quickly. Okay, let me pause this and then type in and then come back. Okay, you see that I have here these matrices 5 1 6 8 0 8 2, 5 1 6 0 8 2, 0 8 negative 2, actually 0 8 negative 2, and 2 3 4 and 2 3 4. You know, the second matrix I have to write here as 2 within another angle bracket. So this is the entire column, entire row I am putting within within a square bracket. So here this is my one row, first row, and this is my second row. But here do not be misled. So you cannot put without these 2 3 and 4 within a single angle bracket, within a single square bracket, or without the square bracket, because each of 2 is the individual element of this row. So I have to put each of the individual element within a angle bracket, square bracket. So this is why I am putting this way, so do not be misled. So then if once I run this, then I will see that is my output is over here 37 16. So this is my output 37 and 16. So one more last operation, that inverse of a matrix, that I will show you. So inverse of a matrix is the trickiest operation in matrix operations. So for instance, if I have a matrix like matrix 1, for instance, here this will be my matrix 4 7. This is my 4, and then 7, and then 2 6, and then 2, then 6. And if I want to do matrix inverse, then I need to, if I, for instance, let me write it down. Then matrix 1 inverse, in order to find the inverse, I need to call np dot, okay, dot linang linalz, remember this way, linear algebra, dot inp, and then within this INP method, within this parameter argument, you will pass your matrix 1. You'll pass your matrix 1, and then you can print, okay, your inverse matrix. Okay, so this one. So then if you print this one, and then you will see you got your inverse matrix is 0.6, 0.7, 0.2, okay, 0.6 minus negative 0.7, negative 0.2, and 0.4. Okay, so for 2 by 2 matrix it is simple, but for 2 by 2 matrix there is a formula, quick formula, then you can remember this formula. For instance, if you have an element A, B, C, and D of a 2 by 2 matrix, this is applicable only for 2 by 2 matrix. Then in order to find its inverse, you can write 1 by determinant, 1 by AB minus AD minus BC, and then times you will exchange A and D. Just you will exchange A and D, so D will go here, and A will go and here, and then you will put negative B and negative C, just negative B and negative C. So that very simple, 1 by determinant times A and D will be exchanged, and minus B and minus C. So this is very simple for it only have a 2 by 2 matrix inversion. So but for a 2 by 3 or 3 by 2 matrix inversion, matrix inverse calculation is trickiest, and for instance this is the formula for a 3 by 3 matrix inversion. This is the formula. You remember that this formula is a large for 2 by 2, although is very simple, but 3 by 3 or for other matrices it is very critical. But using numpy and Python, we can easily find a matrix inversion for any kind of large matrix by using this way. For instance, let me go with an example of a 3 by, like this is 3 by 3 matrix, and its inversion is like this. So let me quickly type in this and show you. Okay, here is my matrix E equal to 1 0 0, negative 5 1 0, negative 5 1 0, and 0 0 1. So then negative E inverse will be np dot len alz dot inverse matrix E. Then if I print and matrix E inverse, then I will get here 1 0 0 1 0 0 5 1 0 5 1 0 and 0 0 1 0 0 1. So don't be misled about negative 0. Actually 0 and negative 0 is same. So this is my actually the matrix operation file. Okay, so I have one more here for matrix, another matrix inversion. So this is working good. So this is my matrix operation file. So once I run this file, you see that I can select the wall course by pressing Ctrl plus A, and then I can press enter. Then all of my course will be executed here. So if I want to delete my previous run, then I can clear console, and then I can run again by Ctrl plus enter. Then all of my course will be run. Or if I want to only run in a selected portion, then I can select it and Ctrl plus enter, and then finally I can save my file, and then it will be saved automatically as my matrix operation. I need to select .py. Okay, so then it will be selected as Python file, then save as, and then it's good. My file is saved as a Python file. So thank you so much. Thank you for watching this video.